Hi students, once again welcome to all of you for online classes in mathematics, that is model 5 we are dealing. Model 5 already we have completed 4 lectures, 5th lecture, and in this lecture uh, in previous lecture number 4 we had one example in which we have calculated the value of k. So the same example, after putting the value of k, the JP table becomes as it is displayed on the board, and for that the same calculation of type 1 that we did previously, once again I am taking, because these are the most important or favorite question that could be asked in the exam. So I don't want to take chance. Once again I will take all the calculation. And one more thing, in previous example we didn't we have estimated up to covariance and we have not gone for correlation. So therefore this time I am including correlation of x and y also. Let's begin. So as you read on the board example, that you have to estimate expectation of x, expectation of y, expectation of x and y. Also you have to go for covariance. So first we will begin with the expectation of x, expectation of y, xy with this table. So in this table you can see that y values are 0, 1, 2, 3, x values are 0, 1. Okay, now whatever you require to calculate expectation or covariance or correlation, first we must prepare the chart of marginal distributions. That is what I am going to do first. So I will begin with the marginal probability distribution of x, and we can prepare the chart very easily as we did previously also. Yes, okay. Yes, gentlemen. So here we are going to take up first the values of x, which we put as xi, and the corresponding probabilities are fx. And what are the x values? 0, 1 and 2. 0, 1 and 2. And what are the probabilities? For probability of 0 you have to add all these 0, 1, 2, 3. So 3 plus 2, 5, 5 plus 1, 6. 6 upon 42. This is 6 upon 42. 6 upon 42. This is the, now for second, 2 upon 42, 3 upon 42, 4 upon 42, 5 upon 42. You add 2 plus 3, 5, 5 plus 4, 9, 9 plus 5, 14. So it is 14 upon 42. So in the similar manner, the next value is 4 plus 5, 6, 9, 9 plus 6, 15, 15 plus 7, 22. So it is 22 divided by 40. So these are the marginal probabilities of the values of x for 0, 1 and 2. Similarly, we can go for the marginal preparation value of the y. Next, marginal probability distribution of, yes, now here there are, you can see in the table there are 4 values. There are 4 values. At the table, yes. Now yj are the values of random variable y, and g of yj are the values of probabilities. So okay, first value of y 0, second 1, 2 and 3. 0, 1, 2 and 3. And for 0, now you have to go for column addition. Column wise you have to add 0, 2 plus 4 means 6. 6 upon 42. So 6 upon 42. 0 plus 2 plus 4, 6 upon 42. For 1, 1 plus 3, 4, 4 plus 5, 9. 9 upon 42. And the next 2 plus 4, 6, 6 plus 4 plus 4, 6, 6 plus 6 is 12 upon 42. And last one is 3 plus 5, 8, 8 plus 7, 15. So 15 upon 42. So these are the two tables of marginal probability distribution of x and y. After this, we will go for expectation. Let's begin. So in expectation, first we'll begin with, now we are going for expectations. Yes, gentlemen, in the expectation, first we will take up the expectation of x. So I will work out here expectation of, first I will take up expectation of x. And the formula is sigma x into f of x. And one by one, x values we will take up. First we will take up 0. So that is equal to 0 and its corresponding value is 6 upon 42. Because it is sigma, so summation. Second is 1 into 1 into 14 by 42. 14 by 42. And next one, the third one is, it is 2 into 22 upon 42. So now when you work out, you will get the result as 58. Is 58 by 42, and which is equal to 29 upon 21. So okay, this is the expectation of x. Let's go for expectation of y. Expectation of y. And expectation of y is equal to, of course, one more symbol is there, you don't forget, mu of x. This symbol also we can use. The expectation of y is equal to, the formula is sigma y into g of y. This is the formula. Okay, that is mu of y. This symbol also you can use. And what are the sigma of y into j? Y is 0 and g value is 6 into 42. So 0 into 6 upon 42 plus then 1 into 9 upon 42, 1 into 9 upon 42, and plus 2 up into all values we will take up and their corresponding probabilities, 12 upon 42, and plus next value is 3 into 15 upon 42 into 15 upon. Okay, gentlemen, this way if you work out what the result of all this is 78 upon 42. You please work out, or you can use your calculators. In decimal also you can write the answers, no problem. So here I am working in fractions, so it is totally 13 upon. So this, you have got expectation of x, this is, and expectation of y. Now third we will go for expectation of xy. Expectation of xy. Expectation xy is equal to what? Expectation of xy is equal to, it is sigma x value, y value, and their corresponding joint probability value. That is, if you take xi yj, ij. So for this table you have to refer. First we will take x value is 0 into y value is 0. For 0, 0 we will take, it is also 0. Plus next with 0, 0 is what? 0 and 1. So it is 0 into 1 into 0 and 1. What is the joint probability? 1 upon 42. Plus 0 and 2, 0 into 2. So I need not worry because everywhere 0 is there. So its answer will be 0 only. So okay. So I will take up this as 0. You have understood? So I will put directly 0 into 0, 0 into 1, 0 into whatever you take, its answer is 0. So with 0 we have covered. Now with 1. So with 1, if I take up, suppose if I work out with 1, so now the 1 into 0 is 0, no need to work out. 1 into 1, that's 1 into 1, and 1 into 1, what is the probability? 3 upon 42, and plus 1 into 2, 1 into 2, or 1 into 1 and 2, what is the probability? 4 upon 42, and next 1 into 3 plus 1 into 3, or 1 and 3, what is the probability? Joint probability? Joint probability is 5 upon 42. So this is the second with 0. Now next we will go for, with 1 it is complete. With 2, 2 into 0 is again 0, no need to write. 2 into 1, suppose 2 into 1 into joint probability is 5 upon 42 plus 2 into 2, and joint probability 2 is 6 upon 42, and plus it is 2 into 3, 2 into 3, and joint probability for 2 and 3 is 7 upon 42. 7 upon. So this all, if you work out, you will get the expectation of x and y. So gentlemen, you work out, and the result that you will get, will be 102 upon 42. Please work out 102 upon 42, which simplifies to 17 upon 7. 17 upon 7. This way. So when you got all the expectations, next you have to go for what? Covariance. That is what? Covariance of x and y. What is the formula? The formula is expectation of x, expectation of x, y minus expectation of x into expectation of y. This is the formula. You can take, instead of this, just I am using both, not confused, you can take mu of x, mu of y. So now when you all values are ready, you can take up expectation of x is 17 upon 7. It is 17 upon 7 minus the expectation of x is 29 upon 21. 29 upon 21 into the expectation of y is 13 upon 7. 13 upon 7. And the result that you will get is what? The result you get is it is 2.486, and its product is minus 2.5546, and when you work out this subtraction, you will get negative of 0.126. So this is the covariance. One answer is Y. That means you have got expectation of Y means this is A, this is B, covariance of. Okay, up to here in the type 1 also we had worked out. Now next we are going for the correlation. Now correlation is what? That means how they are related. The covariance is how they vary with each other during the process of random experiment according to their definition. Correlation means how they are related. That relation we can draw out. We can establish the relation between them. So for that we require, now this we didn't do earlier, so this is first time I am doing correlation. Please see here, for correlation what you require, first you have to estimate the variance of X and Y. Okay, now how to take up the variances? Formula notation is V of X, and that is variance of X is equal to, so this symbol also is there, sigma X square is equal to, now here you have to take up sigma, or you see another symbol is there. So this is for variance, you can take up this symbol, that is expectation of X square, expectation of X square minus mu X square. Expectation of X square means what? In this formula where you have calculated expectation of X, you can see X you have taken. When you take square here, you have to take the square of X. This will be as it is. Therefore, this formula I can rewrite as sigma is the summation of X square into f of X and minus mu of X, that already you have calculated. So let us calculate this. Let us calculate this. Okay. Now X square, come here in the marginal probability distribution table, X square is 0, so therefore it is 0 only, no need to calculate. 0 into anything is 0. Then 1, so 1 square into the marginal probability of this is 4 upon 42. 4 upon 42 plus next value is 2. X value is 2. 2 square, take down, is plus 2 square into what is the marginal probability? 22 upon 42, and that will result in 2. So if you work out this, what you will get? That is equal to 102 upon 42. 102 upon 42. Please work out, you will get. And therefore that is equal to 102 upon 42 is 17 upon 7. So this is sigma X square. But we want, okay, we will take up the variance of Y. Variance of Y again is sigma Y square. Again it is sigma expectation of Y square into G Y square into, okay, this we will calculate, because that is again that sigma Y square means sigma Y square minus mu Y square, minus mu Y square. I think visible there, is equal to sigma of Y square into not f g g y g of y, and that minus mu of y square. This is the formula for variance. And when you take up, this is one by one y values you have to take up here, and there is squares you have to take up. Here you have taken only the direct value, but you have to take up the same, you have to repeat with squares. 0 square is 0, So therefore forget it. Next, for 0 it is 1 square into 9 by 42, 1 square into 9 by 42, 2 square plus 2 square into 12 by 42, 12 by 42 plus last one is 3 square, 3 square into 15 by 42. So this way, in sigma, summation of all these quantities you have to consider, and when you take up this, not mention this, take up mu x value I have not written, all these sigma values when you take up, in that mu x, that is mu x value is how much? Mu x value is how much here? Mu x is 29 upon 21. So that means minus 29 upon 21, its square you have to take. 29 upon 21, its square you have to take up, and that will result into here. So here also, in this all values summation, you have to subtract mu y. What's mu y? Mu y is 13 upon 7. 13 upon 7 square. And this will give you variance. And the variance is, what is the variance? Variance of x. Okay. And I will work out. It is 17 upon 7 is the value of this. In this you have to subtract this minus 29 upon 21 square. Here the answer that you get is, it is in decimal. The is 29 upon 21. This will be is if you work out 0.5215 is equal to 0.5215. So this is the variance of this. Okay, now variance of y, when you get, you have got this. So this will work out to be yes, expectation of is 4.5714 minus, and 13 upon 7 square is 3.4490. And finally, when you subtract it, you will get it is 1.122, 1.1224. So this is the variance of y, and this is the variance of x. When you get variance of x and variance of y, next, remove this, now this is not required. So after getting the variances, you have to obtain the standard deviations. Standard deviations of x and y. Standard deviations of x and y. So what is the symbol for standard deviation of x? That is sigma x is equal to root of variance of x is equal to here root of variance of x. So variance of x is 1 point, which it is variance of x. Variance of x is 0.5215. 0.5215. Here, variance of x is 0.5215. And when you get the square root of this quantity, it will be approximately, it is 0.72. Okay, after getting this, now we'll go for this is the first standard deviation of x. Now second standard deviation of y, and that is sigma y is equal to root of vy. And what is the value of vy? Vy value is there, 1.1224. 1.1224. 1, 2, 2, 4. And when you work out, so you will get the result as 1.06. 1.06. So this way you have got our main requirement is this and this. And with these two, we can calculate the correlation. So what is the formula of correlation? Already in theory we have discussed. So the correlation of x and y, correlation of x and y is given by this symbol, that is rho of x comma y is equal to covariance of x comma y divided by SD, that is standard deviation of x into standard deviation of y, and all these quantities are available. So covariance of x and y is 0. It is negative. This side also you have to include minus 0.126 divided by sigma x. Sigma x is 0.72 into, it is 1.06. And now with this you will get the answer. So what is the answer? The final answer, correlation of this is equal to 0.165, which approximately you can write it as minus 0.17. So this is our rho of x comma y. So this is how you can complete with this. So gentlemen, this is how we are taking the things, and this is exactly the problem we have. Calculated the expected y, calculate the y and x and y. Then with the help of that we have calculated the covariance of x and y, and finally calculating variance first, then SDs means standard deviation of x and y. We have also this formula for correlation of x and y, putting all those values, substituting all those values we have calculated. So this way, this is a complete problem. In the problem, he asks only covariance, or he may ask also the correlation. Whatever may be the case, accordingly, all these calculations are required, and according to this, work out.